I just run the business out of my house. I should have taken a picture of Ian, my intern, who his office is in the garage. And we're pretty much running it like a scrappy startup, where we do real work for real clients, but we keep it pretty low key. So, about 30% of my work is, the goal is to be kind of slow and steady projects that might take a couple months to go from the beginning to the end. 30% of my work is light industrial. It might be equipment anchorage, or generators, or pumps, or when concourse comes to town and they start pulling up all those tents around the county. Monterey County says that each one of those tents needs to have an engineer design it and do structural observations on it to make sure it was built to the design. So I do some designs for those, and I do a lot of structural observations. So in the course of July and August, I think I made, I don't know, about $20,000 off of temporary structures in just 6 weeks. And then 30% of my projects are just simple projects, things that most other engineers would say, "Oh, I'm not going to do that. Like, go find somebody else to do it." Like, I don't have that. It's just a waste of time. And then 10% of my work is restoration contractor that calls me up when a fire happens in a building and they need to get their guys in there to do the demo, but they need an engineer to tell them how to shore it and how to make it safe. So that's basically a as-needed basis of disaster response, and the phone rings and I basically get in my car and go. So this is kind of an example of what the slow and steady work might look like. It was a house remodel that kind of looked like this quote-unquote house in Carmel. And then we were brought in by a developer to...
That's the after?
Yeah, that's the after.
Wow.
To make it look pretty. The slow and steady work, like the per project profit on them is so little compared to how long you spend on it. But it's nice to have those projects there because they fill in the time between the crazy projects that come out of the blue on a Monday and are out the door by Friday, and they make twice as much money as this project that I spent 2 months on. So it's not always the amount of time that I spend on a project, it's the amount of expertise that I'm bringing to a project and the amount of competition that I have from other engineers that are willing to take that type of project. So, when I'm trying to keep it simple, it might just be a beam design. So this contractor who I've worked with for quite a while now, the city told him that he needed to have an engineer design that beam. And that
which beam?
The beam right here, this beam that goes from here to here.
Okay.
That's support from this post to this wall. So they first said, "Oh, you just need an engineer to design a beam." So I designed a beam. And then they said, "Oh, well, you need an engineer to design this shear wall." So I designed that shear wall. And then they said, "Oh, well, we need you an engineer to do the whole lateral load path of that whole carport, and then go back and support these skylights." So this simple beam, which should have normally been just a $500 job out the door in an hour, turned into a $1,500 job that had several iterations going back and But then, so we got that project done, you know, there are tenants living there now. But then the same contractor bought the lot next door to it, and they just issued the building permit for the 2-story house that we designed right next door to it for the same contractor that, you know, was kind of a dovetail into this simple beam project. So you never know like where that simple beam project is going to take you. So you just keep servicing them as if they're a high value client, because that simple beam project could turn into something big. So I always give the same, my goal is to always try to give the same service to a $500 client as a $10,000 client, because a $500 client could turn into a $20,000 client, and a $10,000 client could never cause that. So, you know, you just always try to remember that in my business, where I'm a consulting engineer, where what basically means that I work for people. All right, I own my own company. You know, I'm an employee of Kyler Engineering, but Kyler Engineering works for clients. I don't work for a single company that has a product that makes widgets that comes in. As a consulting engineer, you know, I'm always going out to a job. I go out to 5 job interviews. I'm always closing a deal. I'm always on that side. So part of my time is spent engineering, and part of my time is spent running a business. But this little project was good because the way he wanted to do it, he wanted to use the wrong type of wood on that glulam beam. It would have brought it out in 10 years.
So you actually engineered that beam?
Yeah.
What went into that? Like, how do you
well,
go about that?
I mean, the first step is, you know, I have tables that I, you know, put a dead load table together. That, you know, I say like, you know, my roofing is 2.5 pounds per square foot. And then the plywood is 1.8. The joists are 1.5 PSF. And then, you know, some miscellaneous weight, right? So that ends up giving us 7 or 8 PSF. So that's the dead load, right? Then code says the live load is 20 PSF. There's about, we'll just say 10 feet of tributary load on that. So we'll say that, you know, that's, so you add these together, you get 28 PSF times 10 feet of load goes to 280 PLF, okay? And then basically what statics will tell you is that if you have a beam like this with a loading condition like this, then your moment equals, you know, WL squared over 8. And your deflection equals 22.5 WL4 over, yeah. So basically, you run those two numbers, you get an answer. So I've gotten the beam size in 5 minutes. All right. Look, like just right there, 2 minutes. How long do we spend on it? 2 minutes.
That's worth $500?
That's $500. But the service add that I bring to a project is sizing a glulam takes 2 minutes.
Sizing what?
This is a glulam beam.
A glulam.
So what the way a glulam beam is built is you
It's
have
laminated. It's glue laminated.
Yeah, you have all these pieces of sawn lumber that are glued together to make this beam. But the problem is that water will come in through the ends and rot these things out in the middle. So I've seen that. I've been brought into projects where this type of member has been failing. So this contractor calls me like, I already know what size beam it is. It's going to be this beam. I said, okay, well, let me see. I mean, you're going to pay me $500. It's only going to take you 5 minutes to do this. Fine. So, yeah, there's a value add to that I'm going to be tied to this. So I'm going to make sure it's done right. So I go online and I find the number of a local Houlihan manufacturer. I call them up and I ask for their technical support staff. They patch me through their technical support. I'm like, no, I've got this beam that's going to be in an exposed condition, and the contractor wants to use just an untreated normal Houlihan beam. He's like, oh, no, you can't do that, it will rot. That's what I thought. Like, what do you have? And he's like, oh, well, you're going to need to get a womanized beam. Okay, and he gives me the spec of that. So then I can put the drawing together and say, no, we're going to use this instead because, yeah, it's going to cost you twice as much, but it's going to last instead of fail within 10 years. So that's, yeah, the math only takes me 2 minutes. The drawing took me 15 more minutes. Like,
What about, how long did it take you to convince the contractor to go with the more expensive?
20 minutes.
Was he pissed off?
Yeah, I mean, it's $3,000 out of his pocket.
So you cost him $3,500, not $500.
But he's worked with me enough to know and trust me. That's why he comes to me. Because I'm not going to sugarcoat it. Because I know what happens when you don't do it right. So, yes, there's, like, the math is easy. And I mean, I can give the math to my interns, like they can do that. It's easy. The knowledge to make the right decision, it takes time.
Which is based on experience, yeah.
Yeah, and you have to do it the wrong way a lot of times before you're going to know how to do it. So it's a lot easier, less painful to do the painful learning process while you have supervisors that can look over your shoulder and yell at you before it goes out the door, before it gets built out. So that's the learning process in engineering. When you graduate and you have your degree and you come out of college and think you know everything, and then you walk into an office and they take you down like 4 notches and go and teach you how you don't know anything at all. And it's really time to start learning once you get to the workplace. That's the reality of engineering. And that's the reality of finishing from Stanford. That's the reality from finishing from Berkeley. That's the reality from finishing. Cal Poly San Luis Obispo is probably the only school where you're going to walk out of that school and actually know what you're talking about. You are just talking about engineering. The problem with Cal Poly San Luis is you're going to know how to engineer a very narrow band of structures, or a very narrow band of engineering. Where UC San Diego, Cal, they might not teach you the more practical sides of it, but they're going to teach you the more theoretical sides. So you're going to be able to take those concepts and throw them in more foam and modify them in your own head. So it's just it's the mentality of what you're looking for out of your degree. So the light industrial tends to work a little bit like this, where we'll spend an entire week in August doing structural observations for these temporary structures that they're going to put cars on. This one, I actually did the design for this one. And, a cantilevered wall where it's just acting like a big sail. Like, that's a pretty good design challenge. I mean, there's a lot of different ways to build that. And every contractor kind of has their preferred method of how she wants to do it. And you have to work with what the materials are that they have on in their shop. You can't just say, oh, well, we're going to use this. No, well, we don't have that. Like, we need to do it within this constraint. So even though we designed, I think, 4 different cantilevered walls on this property this year, each one of them was different. Like they don't have any semblance to each other. So it's kind of crazy that that's how it ended up being, but that's what they do big bucks for. And then, I'm out there with with Ian, my intern, and myself. I'm kind of in my engineering tunnel vision, just looking at structure. And Ian's kind of going nuts because there's $2 million cards like sitting everywhere. And, oh my God, look at that! I'm like, what's that? But they're pretty. Not that I know what they are. But, like this one, we were pronouncing it wrong for 4 days until somebody was like, "Oh no, it's a Konisei." Okay, I guess that's how you say it. The on-call structural support was, I was text messaged this picture and I'm looking on my phone and I wrote a contract off of that. And that kind of morphed into, this project that, we put together repair drawings and had it out the door in a week. So, when people are looking for a really quick turnaround, they're willing to pay a significant cost per unit over the slow and steady clients. So, how did I get here? A lot of it was luck. A lot of it was skill. I graduated high school in '99. Started UC San Diego with a major in structural engineering, and I was actually in Eleanor Roosevelt College, which is a college at UC San Diego where engineers don't go. I went to UC San Diego for that because I wanted to do foreign language, and I wanted to do art history, and I wanted to do music in addition to. In 2002, I was accepted to study abroad program after bugging the study abroad coordinator for 6 months. They didn't want to accept me because my GPA was just below their acceptance criteria limit. No, I swear I'll be a good student over there. It's just because I'm doing engineering here that it's too hard. And after being in their office once a week for 6 months, they finally said, "Okay, fine, we'll let you go." So then I got an internship in Italy because my academic advisor needed to sign off on my academic study program, and he saw that there was only history classes on it. He's like, "No, you can't take an entire year off in engineering." I'm like, but that was in the plan. That was what I was going to do. He's like, "No, I can't let you do that. That's why you come by me and have me approved it." So he takes out his little black book. It was 2002. We didn't have, the fancy iPhones and stuff. So, he takes out his little black book and address book and writes down a few different names of contacts to reach out to. And that led to me getting a 10-month internship in Italy. That also led me to getting an internship at UC San Diego. And then I ended up with it in my first, off-campus internship, just by being at the right place at the right time at an engineering dinner. Then I went back to Italy and did my master's at the specialty earthquake engineering program, where we would do one class for a month, take the exam, have a week off, and repeat for 10 months. So, it was 30 hours a week in class and 60 hours a week study. So it's probably 90-hour weeks for 4 weeks. Then you have a week off to recuperate. So it was a little bit intense. And then I worked in San Francisco for 7 years before I moved down to Monterey. So when I was in Italy, I got a little bit of perspective on what was old. So this was built in, the year 30, the Common Era.
Coliseum?
What?
What's the Coliseum?
It's the arena in Verona. So the way that the Romans worked was they basically, as they expanded the empire, they would just build these arenas in each major city that they expanded to. And they conscripted the young population, and then they gave free booze and free entertainment to the population to keep them happy. One of my sociology professors put it in perspective of, it's our modern day equivalent of cable TV and McDonald's. That's basically how the Roman Empire kept its populace in check. So I did a project doing a restoration study on those. Crawling around in the pits underneath the arena floor where they would pop the gladiators up, or the lions or the bears. Stabilizing that back wall, because the back walls fall down notoriously. So we ran carbon fiber through that to stabilize that, so it wouldn't fall down.
For like earthquake protection then, or?
Yeah, earthquake and just time.
Yeah.
But earthquakes, the load that you use on it, but it might not actually be what would make it fall. But because you need something to design to, you use the earthquake forces, but it might just be, it might end up falling down because somebody drives a big enough truck right by it. But it's harder to model that in a computer analysis or the hand analysis. But it's easier to model the earthquake forces. So we use the earthquake forces, and we end up retrofitting for a bunch of other different parts of the code. This was a theater that burned out. It's had, over its 500-year history, it's had a bunch of different fires that take it out of commission for several years on end. And the professor that I was working with was brought in to restore it. So what you'll notice here is, what he did. These are balcony walls that are built out of just red brick. So people, when they're in a balcony watching opera, they tend to lean against the short walls to lean out and watch the opera. Which when you lean against red brick, it just falls over real easy. So what this engineer did was, they did this carbon fiber layup where they ran it vertically here and then continued it back through the floor. So then it makes this L bracket. Because carbon fiber is great because you can lay it up like a fabric, and it's soft and malleable while you're laying it up. And then you put your epoxy resin on it, and then it dries harder than steel. So if you use it the right way and you use specific ties, you can make a nice structural system that's only, an eighth of an inch thick. So, and then we added, all these 20-foot long piers to reinforce the foundation. And then, oops. They ended up with something that looked like that. Another one of the projects we worked on was one of the really old churches in Venice. It's crumbling because the bell tower is pulling away from the building. The soil in Venice, pretty crappy. So this crack right here is just on the inset of the bell tower, so it's actually pulling this part of the building away from it. So the ultimate repair was to end up doing, I think, 80-foot drilled piers that were concrete and steel, and to stabilize that bell tower from rotating still. So basically, make sure that that ground below doesn't move. So the whole practice of engineering is this collaborative effort of this understanding when you're at your limit and you need to bring on a different specialty that knows that material better than you. So I have colleagues that I'll bring into a project when the soil structure interface is beyond the scope of what I do. So I'll bring in a geotechnical engineer to do the soil split. And I have engineers that specialize in carbon fiber, so I'll bring those into a project, and they'll help me assist with the design specification of that. I have engineers that I know that specialize in 3D advanced modeling. So if I need to do this really advanced model for a structural element, then I can bring them in. So it's not doing everything yourself, it's knowing who to reach out to make sure that your project can happen correctly and efficiently and you succeed. And then you also need to know when to tell your client, I'm not the right person for you. I can't write a proposal on you, I don't have the time, or I don't have the expertise. You know, this is huge rejection. So what are we doing with structural engineering? Most people think that if an engineer comes in and designs their building to do a seismic retrofit on it, that they have this nice operational building after. What I try to explain to my clients is that doing a minimum code retrofit on your building gets you to this category, where everybody in the building will live after an earthquake, but the building might be demolished afterwards. The building might not be useful, the power might not be on, nothing actually works. So this is our goal for the building code, the life safety. In collapse prevention, I was just out on a project on Monday or Tuesday where the building's game. It's like I had to write a memo before I came here that was saying this portion of the building needs to be cordoned off and probably repaired. People should be walking on it. The structural members have completely lost their data. So that the collapse prevention, the building has run its life cycle. It's a 30-year-old deck, and it needs to be completely replaced. But on the other side of the spectrum, some clients want their building to be 100% operational after an earthquake. They need that up and running. So to do an operational building, you're going beyond the code. So when you go beyond the code, you're using performance-based design. And I use this to retrofit 10 different buildings on the campus for Bayer Pharmaceuticals in Berkeley. This is when I was working for a different company in San Francisco. And what did I use from that? Or what did I get from that? So we ended up having to retrofit this chemical manufacturing facility without closing down the laboratory for a single day. So we had to do the entire retrofit from outside of the building or above the laboratory spaces. So, it ends up being this structurally inefficient solution, but it's what had to happen because if they lost this building for a day, they're out however $1 million a day that a product that is going through that place. So they just can't afford it. So we, came in and had to do these crazy different retrofits on there. And the fun thing is that you can go on Google Earth and actually see the work that you did. You're like, oh, I did that. That was my design. And it's not always glamorous. Actually, it's usually not glamorous. I've designed, when I was working with that same company that we were doing the air jobs on, I probably designed 20 or 30 different Petcos. Just the little aquarium walls and the food shelves, all the little walls inside of Petco. You're not actually designing the building. You're just designing the little things on the inside. And my industry is just called a tenant improvement. Tenants moving into the space, they're renting space, and they're turning it into a Petco. So, but you don't know where that knowledge is going to take you. So it goes back to that. You always service your clients to the best of your ability, and you're always trying to get them the best product. Because that same knowledge that I took from the Petco projects, I was brought in to be the lead engineer on this student housing project in Berkeley, where they were building the units in a factory, putting them on a truck, and driving them out to the site and dropping them on with a crane. So it's the same design principles that I use for Petco, just in, big with lipstick on it instead of the Petco products. But that was a fun project. That was interesting and challenging, and all kinds of different engineering challenges go into that. How you fit these buildings together, and how you connect them, and how you get the seismic load path to work, and how you get the architects satisfied with not letting the windows line up, but having the load go all the way through to the foundation. So yeah. So what's the whole point? So you never know how long you're going to be doing the profession, how many times you're going to try to give it up and end up coming back to it. But whenever the opportunities come and present themselves, just take them on, learn as best you can from each of those opportunities, and just lock them away, write them down so you don't forget them. I have a few moleskins that I've been carrying around with me for 10 years because they have different projects in them. That I think I'm on moleskin number 6 or 7. Is that one of them gets filled up and it just goes onto the shelf, and you open a new one, but these are my references. These are where the project missives, the things that I've learned, the things that I've taken away from projects get stored.
Can you pass that around? Can we look at that?
Not this one. Nope.
Okay.
You can work at some of the other ones, not this one. But yeah, I have too many NDAs on this one.
So the NDAs?
Yeah, non-disclosure agreements. So I had a project 6 months ago that came in that I actually had to sign my own non-disclosure agreement, and then they actually made me develop one for my employees to sign and send that to the client as well, because there was too much legal ramifications for the project we were working on that could not have. So projects like that coming around every so often. Most of our projects are not like that. We can talk about them freely, and it doesn't really matter, and nobody really cares. but some of them are steeped in legal red tape that aren't for public consent. So you guys have questions, or I can show you some of the projects that end up being more profitable than.
What was your most profitable project?
It might have been like this one, this stupid one that came in, that if they did it on a normal timeline, it wouldn't have made me much money. It would have been a $2,000 project. But it had to get done in 72 hours. Then a bunch of other work to do. And nobody else was willing to do it. So I think I charged them some ridiculous amount of money. $6,000 or something to design on a slate thing. But yeah, I figure Rolls-Royce wants it done, so Rolls-Royce is going to authorize it. So it's just a pair of tires for them. So it's not about the glamour, it's about knowing how to get a project done and work with the team. Which would be, well, I had plans for this weekend, but I guess I'm not going to do them. I'm going to be on a phone all weekend working with the contractor to figure out how to build this. So yeah, most of my projects I don't make like a time limit. I do. I think we're on project number 45 right now for this year. I basically number my projects. We start over at the first of the year. Start on project number 1. And last year I think I had 42 projects come in. They might range anywhere from a $500 project to a couple $1,000 project. Some of them get canceled before we do anything. So some of them get put on the shelf and they don't come back for a year and a half. So you never know when a project's going to make you money until the check clears. You can be really excited about a project, going, yes, I just signed this contract for a $20,000 project. And 6 weeks before you even get it started on it, you get an email. Oh, we decided to go a different route, or we decided to sell the project, or the land, we're not going to do it. So you don't really get to celebrate a project until after the check clears. So you just try to keep your head down and be like, okay, great. We have $40,000 that people owe us right now. Great. You don't really get to spend that money until the checks start showing up. You hope that they will. So that's kind of the hard part of learning the business side is that you have to learn how to leverage the power that you have on these projects, especially like the temporary structures. Most of the time, the check's not going to clear until after the event. So if the project, if the client's going to stiff you on it, you don't have much to hold them to, unless they ever want to. If they want to work at an event again, then they're going to have to pay you. Because the benefit with these projects is that I work in addition to working for the actual vendors that put up these tents. Because I also work for the hosts of the events doing their structural occupations. So I do a subcontract with them to make sure that everything gets built correctly. So if they don't pay their invoice to me, then I have somebody to lean on the event host to say, oh, make sure that this if this company wants to come back, make sure they pay my invoice from last year. So I have that little bit of leverage. a lot of other engineers in this situation.
Do you take business classes to become a consultant, or you just kind of work through each thing that comes up?
I joined a professional society called the American ACEC, the American Consulting Engineering Coalition.
Council?
American Council of Engineering Consultants. And basically a group of owners of engineering companies. They get together once a month, and there's a speaker, and a dinner, and drinks, and happy hour, and that's how I get a lot of my learning, is through that group.
They have a local chapter?
They have a local chapter. It's a great way for me, as you know, I'm the kid in the group, right? You know, and you know, most of the people there are in their 50s and 60s, and you know, I show up and they're, okay, what's your story? Oh well, you know, I'm doing an engineering company. That's what I do. So they give me a lot of resources there and help me understand some of the different things that are available. A lot of it is learning the hard way, getting burned, and moving on from there. Making modifications to my contracts. You know, I rely heavily on professionals that are experts in their field. So I lean heavily on my tax accountant to give me advice on ways to take the company that makes sense for my company. So my tax accountant was who recommended that I incorporate the business. So I said, okay, when do I need to do that? Oh, you need to do it in 2 weeks. What? Yeah, well, it's going to save you a lot of money. So things like that, if you don't have the expertise yourself, you find somebody that you can trust that has the expertise, and you reach out to them, or you figure out who in your network can give you the best advice. You know, be it a life coach or, I mean, I'm of the opinion that I don't have time to take classes.
Yeah.
The amount of it's the time that I would spend in a class that is the drag. I just don't have the time to do it. And that's why when you folks are your age, you need to kind of think as far down range as you can and take as many different classes as you can to give you the tools that you may or may not need in the long term. I don't use my history classes in my day-to-day business operations classes. I don't use my sociology classes in my day-to-day business operations classes. But I would like to think that those classes give me an advantage to my clients that other engineers don't have. And that, you know, I could talk to a lot of different clients and find a common ground that we can relate to. Because people want to talk about what they're interested in. They don't want to talk about what they're interested in. So if you can be more versed on a bunch of different things that a bunch of different people might be interested in, then you're going to be more palatable to them as a consultant, because they're going to want to reach out to you. And they're going to feel comfortable going to you. They're going to feel comfortable writing a check to you because they trust you. And that trust is built over a personal relationship. It's not built over you being the best engineer in the entire world. I tell my clients, you know, I'm not the best engineer in the entire world. I'm not. Very realistic about it. I've worked with the best engineers. I know how they think, and I know how they think differently than I do. And they're amazing. And they work on really cool projects that I have no interest in working on. But I work on these fun little projects that are a challenge to me, and we can have fun doing them. We can figure out a way to do it better, and that to me is a good enough reason to do it all. I don't need to be designing, the next Millennium Tower or anything like that. I've done projects like that, and they give me absolutely zero benefit in like life satisfaction as far as that. I don't take much home from it. So I just say, oh, I don't need to do that to be satisfied. I did this project where they wanted to that picture that I showed you of the structure out at Quail, where I was just on the lawn. So they wanted to put the bottoms of these little legs on this chintzy little bracket that was only, a little sheet metal bracket that was about this tall with a screw on each side. They're essentially a big, huge sail that just sticks up there. And they're saying, oh, well, it'll work. We do this all over the place. But I didn't feel comfortable. So they sent me so we worked with it together and we came up with this. It was a bunch of phone calls and back and forth and me convincing them that this was a better way to do it. But last year when they put this huge behemoth up, every single other event company on the property was looking at that and being like, that doesn't work. Why are they getting away with that? I'm like, well, that's how their engineer designed it. And I told them, after they took it down and they got away with it without having an event, structural failure, or anybody get hurt. Like, I think next year I should be the engineer on this project because we're not going to do the same way you did this year. Like, oh, okay. Well, yeah, we'll do that. So I weaseled my way into that contract, and we developed this connection that works a hell of a lot better. It's a lot stronger, and it goes 5 feet into the ground. And I can actually trust that. And I don't have to sit there and stay awake and worry all night. But is somebody going to die during the day tomorrow with a 70-mile-an-hour gust just comes in and rips the entire structure up? So, a lot of it is, knowing when to say something and knowing when to keep your mouth shut. And just be like, oh, it's not a big deal. Yeah, it might be exactly how it's designed, but it's not a big deal. Versus, no, this is kind of a big deal. This isn't really going to work if something bad goes down. We should do it a different way next year. And people are pretty receptive to that approach of saying, it's okay, we can do this a different way, and it's not going to cost that much more money. We just need to think about it ahead of time. Oh, okay, yeah, we'll do that. Things like that. And I'll say that last year they had a lot of trouble building it. This year they didn't have any trouble building it. So that's the other thing. Yeah.
Aside from actually getting the contract, what takes the longest I am. I am the design process.
Depends on the project. Some projects are technically very challenging, so they take a lot of time doing that. A lot of time doing that, and then the drawings are kind of put themselves together after that. Other projects are mathematically really simple, and it's all about time being spent on the phone sourcing materials or coordinating how to build it the correct way. Other projects, it's completely in the drawings, where it's really complicated to build it, but it's actually easy to design it, and so it takes a long time to build it. So I have this project right now that the engineering on it is really simple. Like the math side of it, really simple. The contract is almost really simple. A half an hour, quite a contract. The drawing is taking forever because it's really a complicated way to figure out how to stabilize this new window seat in this new balcony in the existing conditions. And trying to understand how to draw it, how to build it, how to get everything to work. So every project depends significantly on where it is in the complexity of it all. But this is my current headache that I'm working on. Where we have this, as the architect refers to it, the Romeo and Juliet balcony off of the dining room. And they want to have this little porch roof, and they didn't want to have it would have been really easy to put the members up here at the same height as the floor framing, but the architect didn't want that. That wasn't the aesthetic they were going for. So they really wanted this drop beam. So this drop beam had to be picked up by the floor framing a different way. So there's the engineer's way to do it, and then there's the architect's way to do it. And the architect's who's working with the client, that's what the client wants, so that's what you do. So it's just this whole back and forth of, well, this would be the simple way to do it, but this is how we're going to do it instead, because that's the design. And the math, took me 5 minutes, but the drawings have just been really a bear. And then, this window seat, we're taking out an existing wall, and we're going to build this steel frame that curves around on the bottom and the top, and then you're going to have this whole seat that's just kind of hanging off of the side of the building. Then how do you tie it in at the top? You don't have anything good to come into. So it's how do you get it to hold itself at the top and not just pull off. So a lot of each project is going to have its different challenges and different little idiosyncrasies. Then, when we're doing the site visit, the client pointed out how their deck was leaking. Like they had a patio door onto the deck. It was right over where this beam was. So then I had to analyze that beam and figure out, okay, why is this beam deflecting way more than it's supposed to be? And then I play with the numbers a bit and figure out that you know, the only way that we'd be getting that much deflection is if the contractor, when they're building it, decided to change the spanning condition from how it was designed to be done versus how it was actually built. So I changed the condition a little bit, and I was like, okay, that's how it must have been done because that's the exact deflection that I'm calculating versus what we're seeing. So it's, you know, all kinds of different challenges, especially with the existing buildings. Like you have all these little idiosyncrasies that come in that you have to understand how you're going to approach it and get the clients to trust you that you're going to be able to develop a solution for them.
You know, if I was a civil engineer, I'd be worried about like making some kind of mistake that you would kind of be regretting later.
Oh, yeah,
It looks like you're really careful about not doing that because you've seen issues that people have made before.
Oh no, I made my mistakes.
Have you had any? What was your worst mistake that you regret?
Let's see, let me pull this.
Yeah.
Yeah, so about a year ago, I was brought in to do a project, and great contractor, great owner. You know, when you do a renovation of a house, you kind of put the drawings together based on how you think it is. And then as the project progresses, it morphs because you know, you start pulling off the sheetrock and you say, oh, the framing is doing something totally different than how we thought it was going to. Or, oh, they're 2x10s instead of 2x12s, or they're, you know, just something changes. And I let this contractor talk me into a fix that I knew was not the right fix. The contractor, great guy, you know, wonderful relationship with him, but he was like, oh, those 2x10s are plenty stiff, like, you know, they're gonna be fine when we take out the wall. You know, we just have to strengthen them a little bit. And I ran the numbers and it was right at the limit of where the code would accept a deflection. But if I was doing a design, I wouldn't even gotten near that limit because on a 20-foot span, what the code will allow you to deflect and what you should deflect for occupancy, for people to feel comfortable with it, are two different numbers. So I didn't stick to my guns. I was like, oh, well, the contractor, he's been doing this for a lot longer than I have. He knows what he's talking about. Well, I didn't stick to my guns. He sold me on this. And I ended up owning it. You know, we basically, the way I got out of it was that I owned up to the client and said, you know, it works for code, but obviously it doesn't work for living here. You know, it's my mistake. You know, I should have seen the better solution and done it. And I said, you know, I'll share the cost to make it right with you. And I'll have the contractor itemize this portion of the bill out, and we'll do it the right way, and we'll split it. And it was nice because I hadn't sent her the final invoice, and I was able to just discount my invoice the amount that was
You were getting it.
what I was getting into it. But so, you know, it's a lot easier to donate time than actually writing a check or to, you know, bring my professional liability insurance into it because it was only $2,000 fix. $2,000 for me. But, you know, it was a good learning experiment. I mean, it was basically a $2,000 lesson on learning to, when the numbers were telling me something and when my gut's telling me something, I stick. I don't let somebody talk me into it. Oh, it's fine. No matter how long. I'm the one who has the training to say, no, it's not fine. This is the way we're going to do we're gonna find a different solution for that. So that was basically the biggest investment project, you know, like just understanding school hard knocks.
Yeah.
So, and then, you know, the other one, I guess the other learning process that has come out of, I almost didn't include it because this project has ended up with such a poor result on the end was this one here. You know, last year when I put this presentation together, I was all proud of this because we have a check it cleared. You know, we're all great and happy. But this project has turned into another one that's like that, where a year later, this homeowner is still not in their house. And they've gone through the contractor who my contract was written with, a separate contractor, and now we're on the third contractor. And it's just, I've sunk so much money into this project as donated time.
Wow.
Because I have no contract
Huh.
with them anymore. So that was a part of lesson on writing my contracts in a different way that I write my contracts with the end user, not with the contract.
So are you like completely reliable for this?
Oh yeah, I mean, from a liability standpoint, my stance on it, I don't. Yeah. So the way I look at it, I don't care if they're not getting paid anymore. I have, in my opinion, I have a professional obligation to service the project.
Even though the contract is switching around, so you're like.
Yeah. So that's why I've stopped writing. I've tried to stop writing my agreements with the contractors, and I just write them with the homeowners because you know, the person that's going to live in it, you know, I can put a lien against their house to force payment. But it's a lot harder to do that with a contractor. And there is a way to do it as a subcontractor. You can put a lien on the house. But it's more challenging when there's an insurance company that's supposed to be paying bills. Yeah. So yeah, this one didn't go, you know, last year I was all proud of how it went. It didn't end up being out as much as it should have.
So going forward, are you happy with what you got with your consulting firm? Is this what you're going to be doing for the next 10 years? For retirement?
This is definitely what I'm going to be doing for the next 10 years. What I basically told myself is that, you know, I'm going to give it 10 years, 10 more years, and then reevaluate. And, you know, kind of just do an assessment and see where things are at. And, you know, it might be after 10 years that it's not fun anymore. And I switch gears and, you know, I'm teaching becomes my profession. But right now it's fun.
You worked with a company in San Francisco?
Yeah, I work for 2 different companies.
You're just an engineer?
Just a punch in, punch out engineer.
But you think you learned a lot from doing that?
Oh yeah, I mean,
As far as starting your own business?
the benefit with working in San Francisco is the variety of projects that you get just at once. I mean, you'll get way different types of projects than you'll get working out here. So, you know, a lot of the engineers who are my competition in this town, most of them are in their 50s and 60s. Most of them, like me, worked in in San Francisco for 7 years before they started their own firms down here. But that knowledge is 30 years old. Where I worked in San Francisco, kind of with the 21st century knowledge and training. So I bring a little bit of a fresher voice into it. And then from what I see, a lot of the engineers around here don't stay up with their professional, their continuing education. There's a requirement in California to do continuing education hours for a licensed engineer. But I do have an internal mandatory 20 hours of continuing education that I require for myself.
How many hours?
20.
Oh, a year? Okay. What do you spend that on?
In-person seminars or webinars. So it usually ends up being about 1 8-hour all-day seminar and about 12 webinars. They're 1 hour, 1 or 2 hours each. So I just try to, I do that because I know that there's a lot to learn still. I admit that there's a lot that I have to learn and to gain from this profession.
Yeah.
And the second I come into a project, I've worked with so many engineers that say, "Oh, where's that building going? Oh, it's going nowhere." Ha ha ha. And they have this big joke that their design is just the epitome of design. That they've overbuilt it so much. And they sit there and pat themselves on the back and they congratulate themselves so much. You know what? The world has a really good way to humble you. And I try to never walk into a project and be like, "Oh, my design's the best design." How I did it is the best way. I tell every contractor that I'm working with, if you see a better way to do this, I'm all ears. There's probably 1,000 different ways to do any single structural engineering solution. How I designed it is one of those ways. I think it's the best way, but that's the best way that I know of. I'll have contractors come in and say, "Oh, I think this might be a better way." "Oh yeah, that's great. That's fantastic. It's a way better way." And I, add that detail into my library. It becomes a standard detail. So then I learn on each project that I do. Or they'll say, "Oh, what about this? Can we do this?" No, we can't, because it doesn't work because a nail doesn't hold wood that way. It doesn't work in that orientation. And I walk them through why like that, the simple beam. The reason why this project went through so many different iterations on contractors was because the way that I designed it the first time was using these really expensive rebar couplers. It was going to be $30,000 in joining the two rebars together. And a different contractor thought that he could do it cheaper for a different coupler. So I was like, "Okay, great." And then it turned out that it's still getting too expensive. It's $15,000 instead of $30,000. And then the third contractor came in and says, "What if we welded?" And I was like, "Well, I don't think that you can weld, because there's special rebar for non-weldable rebar." There's two different types of rebar that you can weld and rebar that you can't. "I don't think you can." He said, "Well, do you mind hearing me and looking into it a little bit better?" So, I bought this $300 welding manual and really dove into it and spent 6 hours researching welding and came up with a fix that actually works for non-weldable rebar. So that I had to. It was $300 plus the entire day of my time.
What did you end up doing for this project?
I figured out how to weld it with non-weldable rebar. It's a special heat treatment that you do. You have to bring up the rebar to 300 degrees Fahrenheit on preheating.
But the rebar was rusting out.
Well, no, there's a when we deal with steel, there's different alloys that are different compositions of steel, and the normal rebar that we put on most projects is what's called grade 60 rebar. But that just means that it has a minimum strength that it's been tested to, but it doesn't have a maximum strength that it's been tested to. So what happens is they take old cars and they melt them down, and all the high strength steel that's in the old cars goes into rebar. So it is coming out with this carbon content that when you heat it the wrong way and cool it the wrong way, it'll become really brittle. So if you weld it without the right treatment on it, the weld will look like it's strong, but the second you start loading it, it'll break because it becomes brittle. Because it's not the right amount of carbon to iron ratio in that bond. So I was of the opinion that I was always told that you cannot weld non-weld rebar. The rule that I was always told. And this welder knew enough to push back and he's like, no, I've done it before. We just have to do something special. Can you look into it? I'm like, yeah, I'll look into it. I'm always game to learn. So instead of just sticking to my guns and being like, no, you just can't do it. That's what somebody else told me. I looked into it, and sure enough, there was a way to do it. It's just a special process and a special heat treatment. So there's only specific types of weld that you can do in that environment, but you know, it all ended up working. So they were able to do it for pretty much the cost of labor instead of $30,000 worth of parts that they're never going to get money being paid back on. The materials side of it was really cheap. It was just all in. And it's a lot easier to get your money back when it's just labor versus parts that you actually have to buy and then convince somebody to pay you. That's why, you know, being in my business, I have a lot more wiggle room on fees and things like that because it's all time. Time spent here or time spent, you know, building it.
Would you say the difference between a structural engineering degree and civil engineering degree?
In practice? No.
And civil engineering, is that a broader scope of work?
Yeah, I mean, it depends on the curriculum. Like if you come out of Cal Poly with an architectural engineering degree, it's pretty equivalent to a structural engineering degree from UC San Diego. If you come out with a civil engineering from Cal Poly, you're going to be a lot more raw. You know, you're going to be taking a lot of different classes. So, but you're going to take a few different structural specialty classes. So it ends up being, you know, the technical electives that you take in your field. Where, yeah, at UC San Diego, there was no civil engineering. It's all structural. So the only technical electives that you had were different technical electives within structural engineering. So I could choose between non-destructive evaluation, seismic design, wood design.
Do you think getting a license to be an engineer was more difficult because of that?
The survey, so the civil engineering exam is broken into 3 different parts in California. You have your general part, that's general, it's 4 hours of general civil engineering, and then 4 hours of specialized civil engineering. So the 4 hours of general civil engineering was challenging for me, but I was able to teach myself enough out of this big, huge study book that they gave me that I could pass that. So I passed the general, the 8-hour portion. So basically you have the 8-hour portion, then you have these 2 specialty portions, one seismic design and one surveying. The seismic design, I passed the first time. The 8-hour portion, I passed the first time. The surveying portion, I failed twice and had to take a special class that was just designed to pass a surveying exam. It wasn't designed to teach us how to survey. It was just designed to pass the test. And the teacher was very clear that, if any of you are trying to go practice surveying, leave the room right now, because I'm not teaching you to practice surveying. I'm just teaching you to pass this test so you can have your license. So I studied really hard, and I was studying 5 nights a week and all day in class on Saturdays for 8 weeks, and then I was able to pass the test, the surveying test. But that was the biggest challenge coming from a structural engineering curriculum. We didn't have a surveying class. Or if you came from a civil engineering curriculum, you would. But I would say for mechanical, electrical, all the other ones, you're pretty much clear to do whatever you want. And one recommendation that I would recommend to everybody, whether you think you're going to get a licensed engineer or not, is while you're in school, while physics is still fresh in your head, take the fundamentals of engineering exam. Because that's the first test that you have to take to get your professional license. You don't have to renew it, you don't have to do anything for it, but you have to pass that exam before you can get your EIT, your engineering training, which is the first step in the whole licensure thing. If you wait till after college to take that test, it gets a million times harder. Because I was saying that you walk out of college and you think that you know everything, and then you get to work and you don't know anything. Well, in order to learn all the things you need to learn to do work, you forget all the things that you didn't need to have in college. So the fundamentals of engineering exam is all that crap that doesn't matter in the workplace that matters in school. So take that test. It's an 8-hour test. You need to pass it before you can get your license. And whether you think you're going to get licensed or not, just take it while you're in school.
So what do you think what's more challenging, the school part or the people part? Don't you actually meet the client and you have to deal with different contractors, you deal with clients and their needs and all that stuff? Do you think that's more harder to tend to a specific need and work with communicating with people daily, which you might have disagreements, or schoolwork and going to college and
it depends on you. For me, I'm an extrovert. Dealing with people jazzes me up. I get really high off of it, and it makes me happy. And it's really hard for me just to buckle down and do one thing for 8 hours. It exhausts me. It just drains the hell out of me. So the school was always really hard. Where dealing with clients is my work. Where a lot of my friends who are just badass engineers hate dealing with clients. They hate when that's like. And they do it because they have to, otherwise they don't make money. But they hate it. They hate that part. But for me, that's the best part of it. Doing the work is what exhausts me. I hate it. That's, I was just joking with Tom before I started here. I was I just need Tom to come in and help me with getting this backlog off my desk. Because it's all that. It's all the stupid piddly shit that's drafting. I know everything that needs to go in.
You just clone yourself for a couple days.
Yeah. Well, no, I need to clone somebody who's an introvert that doesn't like talking to people, that just wants to go into a hole and do engineering for 20 hours.
My hole is already filled with stuff.
Yeah. No, it's I need, basically, I need my foil in my office
Yeah.
because somebody that has my strengths,
Then you need a partner, huh?
yeah, it would be really nice, but there's until the next recession happens, there won't be any available. But yeah, when the next recession happens, then I'll pick them up. But right now, I can't do that. Right now, it's just, I bring it, I have my interns as profitable as they can be, but I'm the bottleneck. I can only do so much engineering. So I can't tell you what's going to be hard for me.
Yeah.
What I will say is that I wished I had played to my strengths earlier in my career and understood what those were than trying to get jobs that were like my ideal job that wasn't actually the right job. So understanding what makes you happy in your day-to-day life will alleviate a lot of the professional pain that might come. So it's just knowing what makes you happy. Like what can you feel like at the end of the day? That was a good day. Like, that made me really happy and satisfied. And searching for that fulfillment, and then latching onto that and be like, that's the type of career I need to go to. And taking that, and that'll take you for this in your personal life and your professional. Because your personal life will be better if you're doing every day thing on a day-to-day basis that makes you feel like you're contributing what you need. If, I had a job for 2 years where I was living inside a computer. I worked on Excel spreadsheets that were 150 megabytes. I had to upgrade from Excel 2003 to 2007 because I ran out of the 27,000 rows. I need more rows. Oh, I have to get the newest version of Excel because I needed the 65,000 rows. And it was just, I thought that was the type of job that I wanted to do in my life. And I just realized that it was really exciting for the first 2 months, and then it just became horrible because I get jazzed with people interaction. And I need to be living in a computer for months on it. So it was emotionally exhausting. So knowing that about yourself, of like what makes you happy and fulfilled, will direct your path. But my answer is not to be your answer. Finding mentors that understand that about you, and that when they tell you something, you actually listen.
Cool.
Any other questions? So we're out of time, folks.
What was the name of the test you were saying to take?
The fundamentals of engineering exam, and that's to get your EIT license. So it's actually an online test now. So they used to only offer it twice a year. Now you can just go into one of those testing centers and schedule it.
Cool.
But yeah, so it's a good test.
Oh, well, you learn calculus and physics and chemistry and everything.
Yeah, it's mostly like I don't even think there's much calc on it. It's all physics.
Really?
It's all. I mean, you have to when you register, they give you this little study book. It's 30 pages long, but it's so much breadth on it that after you've done your base level engineering classes, you're probably qualified to take it. But I would just say, okay, well, I'm going to know all of the statics because that's what we do in structural engineering. And I'm going to know of the 30 different thermodynamics questions, I'm going to know 2 of them. So I've never taken thermodynamics. I've only learned thermodynamics and physics. So I would answer the 2 that I know, and I would just level C for the rest of it, and just move on. because wasting your time on the ones that you're not going to know, it's stupid. So you just sit there and guess on the ones that you're not going to know, and then you move on to the next ones, and you basically pass the test that way because you take the ones that you know you're going to know and you study that. You make sure that you're going to ace that section. Don't miss those ones. Don't miss them if you know, like your bread and butter, whatever that is for you. Make sure you know. And then the other ones that you're not going to know, like I was the same way with electricity management. Structural engineers don't do electricity management. So I was able to answer the first 5 questions from my physics class, and then the next 20 were just completely Greek. So I just those are like variables that I never even studied. So how am I going to answer those questions? So you basically just go that way. So basically, go on, see which genres there are going to be, and my instinct is that you're not going to be able to do it until after your first year, after you leave MPC. You probably won't have the right class load experience, but it's going to be soon after that you're going to take it. I think I took it before my senior year because your senior year you start getting a little bit too specialized, and you start that culling of information in your head. I don't need that anymore. I'm done with that. I've gotten through that class. So you want to catch it before that information gets just completely neglected.
Yeah, totally. Yeah, otherwise all that studying is for nothing.
Well, yeah, and I have so many friends that took bright people, and they waited until they had been working for 3 years to take the fundamentals of engineering exam. They took it 4 or 5 times. You're a great engineer. Why do you fail in this class? Well, because it's hard stuff.
The things there are some people that just hold on to stuff really well, and other people forget it real easy and they just learn it really fast. And then going to figure out what your style is.
Yeah. So it depends on how you process information. I'm like, if I don't use it, it's gone. When Tom asked me to teach him that, of course I was like, yeah, sure, that was 10 years ago. I can do that.
You're a quick study.
Yeah.
Well, thank you, man.
Yeah.
Definitely a really interesting perspective in engineering that's from other different types of people we've had. Completely.
You're not going to get very many engineers that are as candid as that.
Yeah,
so,
very candid. Yeah.
I'm pretty honest to a fault. So.
Yeah, it's cool to see what you actually do on a daily basis too.
But it can be really boring sometimes, but it can really crush you. I didn't download the pictures yet, but I just got this. It's a really cool email. Right before I came home.
Oh, yeah.
It's 2 shipping containers stacked, or 4 shipping containers stacked on top of each other. And it's a temporary installation for Porsche.
Here?
It's in Sonoma County, apparently.
Huh.
Sonoma County just told them today that they need an engineer.
So they called you?
Well, they called the secretary at Quail Lodge that were like, who does the engineering for you guys? She's like, oh, call Matthew. Send me an email. This is kind of a out of left field question, but can you do this? I know that there's going to be a huge cost premium on it because we need it done right now. I was like, how fast is right now? As soon as humanly possible. Do you realize what the cost premium is for as soon as humanly possible?
Wow, cool.
Yeah, so that's a.
Sounds like a Christmas bonus for you.
Yeah, considering like, if I can get this week's workload off my plate, I'm pretty sure with the workload that this week, then we were set for the year. Everything, that's just.
Yeah. Well, I love that kind of lifestyle. That sounds really cool. I envy that. I just think we really get a consultant engineer.
Hey, I can make room for you.
Yeah. All right. Well, let's talk. Well, thanks, you guys. So we are a week late in starting our tower competition, but with the opportunity earlier in the week for Predator Guy and Matthew, I just thought this was really kind of worth the wait. So we're going to dive in next week on our bamboo tower project. Actually, why don't you take the handout with you and start thinking about what you're going to do for it. You can start sketching out some ideas for how it's going to work. We're each going to get 100 bamboo skewers, each team. And hot glue and wire. And if you want to hit up Matthew for some ideas before he goes.
I just wanted to see in case
You want to grab dinner after this?
Yeah, I was going to say it. Want to do it? Sure. Later on, or you need that? Yeah, it might be something. Wherever you can. Sure. All right. Follow me.